Hello, welcome to the class. Welcome to Learning Outcome 4. It's about understanding calculus and relevant engineering. Understanding calculus and actually what's relevant engineering. So this class is going to be in two parts. So the first one is about how to differentiate. So differentiation just means similar things like finding the gradient, the rate at which something actually was changing. That's differentiation. So we're gonna do this LO4, and this is like calculus. This is like calculus. So we want to look at that. So differentiate with a function. So it means what rate? So when you see the y, the x, it means that the rate at which y is changing with respect to s. So this is the y, like a Greek word. The rate at which y is changing with respect to x. That is it. The rate at which what y is changing with actually what with respect to x. That is the y dx. So it's very important that you actually that you know this. So let's look at few examples now, and we're going to look at the application too. Just few examples. Then we also look at how to actually apply the knowledge of these. So so let me just post it. So I'm going to send notes across to you. We have the PowerPoints already. So look at that's the y dx. So when you're talking about gradient is what gradient of a curve is defined as the tangent of that curve. So if you have a curve like this, they ask you to find the gradient. So you know that that's going to be the gradient. That's going to be the line. You draw a tangent. You now find the gradient of that tangent. That gives you the gradient. So in some cases too, we can actually do in so many cases we can it can cause it can be a cubic curve. It can actually cut across. So when you are trying to, if they ask you to find the gradient of a curve, so they draw a curve for you, and you ask to find the gradient of this curve. So maybe this curve, and you have so just show the curve. So you have the curve. You have so that's the curve, and then you have a tangent. So it's again, sorry for that wobbly line. The tangents come across it. So the point here, the point there. So the point across that point is going to be that point A. That's going to be 2 to 1. That's 2, 1. And the curve equation is y, x. The curve is y equals to x cubed minus 2x minus x plus 3. So you ask to find the gradient at point A, and they give you the curve like that. The gradient at point A, and actually gave you the curve like that. So it's just for you to. So at that point, you can actually differentiate, and you substitute the value of x in there for you to find the gradient. you can differentiate this function and actually what substitute the value of x there to find it out. So let me just talk you through how to differentiate. It's very, very straightforward. So for example, now if you have this is a general formula. If you have you always have functions like this, a, and you have x to the power of n. So if you have to differentiate that, the y is a function of this, the y dx will be, you take 1 away from the n, then you put it on the side. So it's going to be what? N minus 1, a, multiply by a, multiply by, you do that one to be, sorry, put, sorry, one sec. Just has to be, it's just a new board that is showing. So it's going to be n, a, x, n minus 1. So that is it. So the first example is this. So if you have something like, you say you should find, you say y equals to 5x cubed. So what you have to do is you just need to do the y, the x equals to, you move this one here. That gives you 3 times, 5. Then you put the x there, 3 minus 1. So that gives you 15x squared. And you see? So you move the 2, so you move what's it called, 3 to the side, so that you take away from it. So that is it. So I'm going to write some on the screen, so you pause the video. You can actually have a go on some of them. So I'm going to rub this off, and you can actually have a go on some of them. So quickly, so the first one you can do is just a y equals to, you find the y dx for all of them. Y equals to x squared. Y equals to 5x to the power of 4. Y equals to minus 4x to the power of 5. Then y equals to 2x to the power of minus 4. So you can have a go on that, then I can come and solve it for you. So have a go on it. So let's look at it this way. So solution. So differentiate this one. You bring the 2 here. That gives you what? 2x. Then gives you what? 2 minus 1. That gives you 2x. Then this other one too. You move this one here. That gives you 4 times 5. Then x times x 4 minus 1. That gives you 20x cubed. And this one too, that gives you what? 5 times minus 4. X to the power of 5 minus 4 minus 1. That gives you minus 20. X to the power of 4. Then the last one, this one gives you what? Minus, you put this one here. Minus 4 times 2, that gives you minus 8. X to the power of minus 4 minus 1, that gives you what? Minus 5. So just try and have a go. Just try and check your work too, if you got it right. And if you don't actually get it right, just try actually make correction in that regard. So you can just try and actually make correction in that in that regard. So thank you for that, and we're gonna try and move on now to someone slightly more tricky questions, so that you're gonna be aware of doing that. So if you have something like y equals to, if you have something like y equals to 4 over x, 4 over x squared. So you are asked to differentiate this function. So this function is slightly not like the usual one. It's just a bit different. So you have to apply, indices first. It's to it before you actually differentiate this. So that gives you y equals to 4x minus 2. Because when you see that this one is like 4 times 1 over x squared. So it's good with 4 times x to the power of minus 2. Can you see? So you can actually see that 4 times 10 to the power of minus 2. Four times x to the power of minus 2. So that gives you just differentiate that. That gives you dy dx will be equal to minus 8x minus 3. The power of minus 3. Can you see? Minus 8x to the power of what? Minus 3. So you multiply the minus 2 times 4, that gives you minus 8. Then minus 2 minus 1, that gives you what? Minus 3. So that is it. So don't forget these type of questions. You have to make sure you turn the indices first before you actually do it. So you can also have a go on like just 2 of the questions like this. You have a go on it. Pause the video. Just try and pause the video. Y equals to 3 over x5. So it's good what? Y equals to 3 to the power of what? X minus 5 minus 15 x to the power of minus 6. That's the answer for that. So, okay, that is it. Thank you for that. So let's now move on to sometimes you can actually be written together. So it can actually be written together in some situations. So let's try and look at it in situations. So sometimes you can actually witness things like sometimes you can actually witness things like they give you y equals to like 4x to the power of 4 plus 3x squared s cubed plus 2x squared plus 4x plus 5. Can you see? You have this long differential. Parts are just going in. So it's not difficult. What you have to do is just differentiate it individually. So that gives you this one goes 16x cubed plus this one gives you 9x squared. This is 4x. This is going to be what? No, because this one is going to be ordinary 4. There's going to be actually what will be ordinary 4 there. Then because there's no function, there's no x function on 5, so it's going to be 0. This is going to be the answer. So it's not difficult. What you have to do is to differentiate it individually. So when you differentiate it individually, it's going to work for you. That is actually the most important thing part there. Differentiate individually. When you do that, it's going to actually work. That is actually more straightforward. So let's just go back to finding gradients of a curve. You want to find out gradients of a simple curve using the graphical method. So let's look at this curve, and so if you have a curve like this, those are the one I actually drew initially. You have a curve like this. So apologies, this one is just there. Then you also have a straight line. So you have a straight line like that. Let me see, maybe it can be better. So at this point, it says 2 to 1, just like 2, 1. Then the curve, the equation of the curve is this. The equation of the curve is y equals to x cubed minus 2x squared minus x plus 3. This is y, this is x. So now the first thing you have to do basically is that for you to differentiate that one to find the gradient, you differentiate the curve. That gives you the y dx is going to be with 3x squared minus 4x minus 1. That's the y dx. So that's going to be this for the gradients, you know. So now you have to substitute the value of x. You know, in this coordinate, you have what? X to be 2 and y is 1. So you now substitute the value of y of x there. So it's going to be 3, 2 squared minus 4, 2 minus 1. 2 squared is 4, 4 times 3 is 12. 12 minus 8 minus 1, that gives you what? 3. So 3 is what? Is the gradient of this curve. The 3 is the gradient of what? Of this curve. That's it. Can you see? Just differentiate the, what's it called? The equation of the curve. Then substitute the value of x in there. Then from there, you already find the, you know, the answer is actually there for you. Don't forget that it's just a very simple method. The same approach, differentiate it. Then you substitute the value of x. Then that is fine. So let's also look at how to actually find the coordinate of the minimum and also the coordinate of the maximum point. So you can also use differentiation. So for example, now you can say a curve has equation y equals to x squared minus 4x plus 21. Find dy dx. So just differentiate that. Then now find the minimum points to find the minimum points. So differentiate this one, that gives you what? 2x minus 4. That's that. So when you ask to find the minimum point, you have to set the y dx equals to 0. So the y dx equals to 0. 2x minus 4 equals to 0. Then that gives you what? 2x equals to 4, x equals to 2. So if x equals to 2, what's going to be y? You know, y is already x squared minus 4x 21. So x squared, that gives you 2 squared is 4. 4 times 2 is 8 plus 21. So everything actually will give you 17. So it's going to be what? 2, 17. That's the answer. 2 and 17. That's actually what the answer. 217 is the answer. So that's the minimum point. So the same thing too, you have to actually do for the stationary points and actually what for the maximum too. So let's try and actually what to do some other questions. So let's just try and do a slightly other question on this. y equals to x cubed minus 1 over 2 x squared plus ax plus 1, where the a is constant. So the curve has a minimum value, has a maximum value of minus 2 over 3, 49 over 27. That's the, and the minimum value is 1. 16. So differentiate this one first. So dy dx equals to 3x squared minus x then plus a. Before I differentiated that, said that so if you know x equals to 1 and x equals to what? Minus 2 over 3. So for both of them, you know that is going to be what? X minus 1 minus 2 over x. No, x equals to minus 2 over 3 and x equals to 1 for both minimum and maximum. So that gives you, this second one is going to be 3x plus 2. Everything equals to 0. So when you differentiate it, 3x squared plus 2x minus 3x minus 2. 3x squared minus x minus 2 equals to 0. A equals to minus 2. That's it. And you see, when that's a equals to what? A equals to minus 2. So you go that one straight away. So it's a very straightforward. Don't forget to actually try and like practice more questions. Go to the model and you go to some questions there and actually try and like practice more of those questions. So that's for the other part. So then you can be able to have a go on the model. So the next part is for us to look at how to differentiate sines and cosines. Then we can now look at how to actually apply knowledge on it. Thank you for joining. See you next time.